Hello, am I audible?
Yes, sir.
Good evening, sir.
Am I audible, Arpit, Naziha, Sakina?
Yes,
Yes,
sir.
sir. Good evening, sir.
So in the last class, we have finished up to potential. The next topic is potential energy. So for potential energy, you have few relations. Like the first one is the potential energy of 2-point charges. So if you have 2-point charges, one is Q1, another point charge is Q2, and they are placed at a separation R. You want to calculate the potential energy of the system. So the relation for potential energy is K, Q1, Q2 divided by R. This is for a system of 2-point charges. So if you have more than 2-point charges, then what we will do, we will calculate potential energy due to each of the individual charges, and then we'll calculate the total. See this question number 4. You have 4-point charges, capital Q, small q, small q, place it. Find the resulting electric force and potential energy of the system. Electric force we have already calculated in Coulomb's law, so we will not calculate electric force here, but yes, we will calculate potential energy. So for the system of these 4 charges, first of all, decide each side is A. Then we can easily calculate the diagonal, which is A root 2. We can calculate this diagonal also, which is A root 2. So what you will do here, you will calculate the number of interactions, and then you will write potential energy for every interaction, and the potential energy of every interaction is this, K Q1 Q2 by R. So you have a charge capital Q, you have a charge small q, and the separation between them is A. And you want to calculate the potential energy of the system. So that's K, it's capital Q, it's small q divided by A. Similarly, you have capital Q and capital Q here. They will interact, and the potential energy will be its K. It's capital Q, it's capital Q, separation is A. So see, this capital Q can interact with the small q, then this capital Q can interact with this capital Q, then this capital Q can interact with the small q also. So it's K, it's capital Q, small q divided by A. So these are interaction, capital Q with small q, capital Q with capital Q, capital Q with small q. Then you can write interactions of small q. Small q can interact with this capital Q. But we have already counted this interaction, right? When we say that capital Q and small q interact, so we have also counted this interaction, small q with capital Q, already counted. This small q will interact with this capital Q. Arpit, what will be the expression of potential energy due to interaction with small q and capital Q?
Sir, that we already did, right?
No,
KQQ by
no,
A.
no. That is for this capital Q and small q. We're talking about this small q and capital Q. They're different charges, no?
Sir, K capital Q small q by A.
Then this small q can interact with this small q. Nazia, what will be the expression of potential energy, small q and small q?
KQQ divided by A root 2.
Yeah, K, Q. Now this small q can interact with this capital Q also, right? But we have already counted this interaction, so all interaction of small q is over. Now let's check the interaction of capital Q. Capital Q with capital Q is over. Capital Q with small q it's over. Capital Q with this is small q, this is left. So this capital Q can interact with this small q, and the potential energy will be K capital Q small q divided by. Now you can just add them up. So the total potential energy is, you can take some terms common, K capital Q by A you can take common, and here it's 1. Here it's 1 by root 2. It's 1 again. It's 1 again. It's 1 by root 2 plus 1. So there are 6 terms now, 1, 2, 3, 4, 5, 6. Right? So the potential energy will be, it's K Q cube by Q. So this 1, 1, 1, 1, 4. 1 by root 2 plus 1 by root 2, it's 2 by. This is the expression of potential. Now, along with potential energy, they can also ask you to calculate the work done to make the system. See, the work done to make the system is exactly equal to potential energy. So that is just K Q Q by A, 4 plus 2 by root. The next question that can be asked is this system bounded or unbounded? So bounded system means system where charges attract each other. Means a system of a positive and negative charge is a bounded system. System of positive and positive charge is not a bounded system. It's an unbounded system. So to decide whether your system is bounded or unbounded, what we do, we calculate potential energy. If your potential energy comes out to be positive, that means it's an unbounded system. So here your potential energy is positive. See, all charges are positive. So potential energy is positive. That means the system is unbounded. If your potential energy comes out to be negative, that would mean it's an unbounded system. Sorry, if it comes out to be negative, that would mean it's a bounded system. But here potential energy is positive, so system is unbounded. Is it clear for everyone?
So I have a doubt.
Yes.
So the interaction which you wrote at the first and the interaction below it, sir, aren't the same?
No. See, it's not just about the magnitude of charges. This capital Q and this capital Q are the same charges. They have same magnitude, but the charges are different, na? Different particles. So this
Okay.
interaction and this interaction, this and this, the different interactions between different charges. Although they have same magnitude, you'll get same expression. But particles are different. So it's a different interaction. Clear, Pith?
Yes, sir.
Anshika, Hishma? Okay, note it down, then we'll move on to the next question. This one
So
was.
this is a 2-marker question.
No, it's 3-marker usually. Yes, written.
Yes, sir.
Sure. So after this potential energy, then you have another relation, which is potential. This is a lengthy question. If it comes, it's usually a 3-marker. 3-marker or 5-marker question. This is a solid example of NCRT. And it's a lengthy question. See what concept we'll use here. So earlier, the relation that we wrote was for potential energy of 2-point charges. But instead of 2-point charges, if you have an external field, and in this external field, you place 2 charges, one charge here, Q1, another charge here, Q2. So if you have field, that means you have potential. Huh? So you have a potential V1 here, and you have a potential V2. So, and the separation between the charges is, let's say this is R1. We will have a number of interactions. The number of interactions are, see, Q1 will interact with the field, just one interaction. This Q2 will also interact with the field. When I say interaction, then I mean force. Q1 will experience a force due to field. And we write it in this way that Q1 will interact with the field, Q2 will interact with the field, and Q1 will interact with Q2. So we have 3 interactions. That means we have 3 potential energy. And how to calculate that potential energy? To calculate that potential energy, we use this relation, charge. For interaction of charge and field, it's simple. It's charge multiplied by potential. Again, charge and field, it's simple. It's charge multiplied by potential. If you want to see interaction of charge and charge, then it's the same relation that we did in the previous section, K, Q1, Q2 by R. So this is interaction of charge and field. If you have a negative charge, put charge with a negative sign. Now, in these type of questions, the major issue is this V1, this V2. In these type of numericals, the toughest part is to get V1 and V2 and see how to calculate V1 and V2. So determine the electric potential energy system consisting of 2 charges, one is 7 microcoulomb and another is -2 microcoulomb, placed at -900 and 900 respectively. How much work is required to separate the 2 charges infinitely away from each other? So right now there is no electric field. You just have 2 charges, one charge at -9, another is +9. So this is one charge here. We're solving this numerical. This is, let's say this is 7 microcoulomb. This is placed at -900 centimeter. Then you have another charge which is -2 microcoulomb. This is placed at 900 centimeter. What's the separation between them? This will be 9 or 918 centimeter, right? So if you want to calculate potential, see, whenever he asks you to calculate work done, that simply means you have to calculate potential energy and then you can equate potential energy with work done. Don't attempt calculating work done. It will be a very tough calculation. Always calculate potential energy and work done is potential energy. Now let's see. See, these 2 charges are interacting. So it's simply K, Q1, Q2 divided by R. So K is, it's 9 into 10 raised to the power 9. Q1, Q2, it's 7 into 10 raised to the power -6. Q2, it's -2 into 10 raised to the power -6. Divided by R, which is 18 centimeter, 18 into 10 raised to the power -2. This 9 and 18 will get cancelled out, that's 2. This 2 and 2 will cancel it out, which is -1. So you get potential energy is, see, this is 7 into 10 raised to the power, it's 9 minus 6, which is 3. And it's a negative sign, right? 3, then 3 minus 6, which is -3, -2 will come, it's -1. So it's minus of 0.7. Yes, Arpit, Hishma, Akshita, Anshika, any doubt up to here?
No, sir.
We have to convert it into significant.
Sorry,
These points.
Arpit.
Can we leave in the state -7 into 10 raised to power -1, or we have to convert
That's your
it?
choice. That's your choice. You can leave it. Don't worry about this. These and this are same thing. Huh? You can leave anywhere. It's not even an issue. Okay, the next thing is after this, The next is how much work is required to separate the two charges infinitely away from each other. So if you want to separate the two charges, means you want to break the system. Huh? So work done to break the system is just negative of potential energy. So it's minus of minus 0.7. So you will get 0.7. This is the work done to break the system. Then this is how much required to separate the two charges. And second is suppose the same system of charges, not now. This is the twist. Huh? Now you have electric field also. This is the electric field. So this is electric field. So earlier you had just two charges, one Q1, another Q2, and they are placed at a separation of 18 centimeter. But along with these two charges, you have field also. So what will be the change in the relation now? Nazia, how will the numerical will get modified due to the presence of electric field? Nazia. Sakina. So along with charges, you have field also. How will this numerical will get modified? Okay, can anyone answer this question? What will happen if I apply field?
So potential.
Yes, we will have potential. Okay, Nazia, can you just tell me the number of interactions now? The number of terms in potential energy?
Q1 with Q2,
Mm-hmm.
Q1 with electric field, and Q2 with electric field.
Okay, so what are the total number of interactions now?
3.
3. Now, can you tell me the formula, the relation that we'll use here for this particular interaction? What will the formula? Okay, you can do one thing, at least note down the relation and the first part of the question, then we'll start the second part. At least note down this relation.
So done.
It's okay. Sakina, written? Anshika,
Yes, sir.
written this relation?
Yes, sir.
Can I scroll it down?
Yes, sir.
Okay, Sakina, now can you tell me the relation that we're using here? Hishma, will you try the formula that we're using here to calculate the potential energy?
So it is Q1 V1
Mm-hmm.
plus K Q1 Q2 by R
Mm-hmm.
and Q2 V2.
See, this term we have already calculated. We already know what this term is. It's minus 0.7 joule. Now we need this Q1 V1 and Q2 V2. Anshika, just read the question and tell me, is potential given? Just read the whole question and tell me, is expression of potential is given?
No, sir.
No. Anshika? Can you find the expression of field here? Sorry? Anshika, can you find any expression of field here?
Sir, external field is given.
And what's the expression?
Sir, E is equals to A 1 by R square.
A by R square. Field is given, but for this relation, you need field or potential.
So potential.
So can you think of something like which can relate field and potential, like which can convert potential in terms of field or field in terms of potential? You have field. Field is given, right? E is A by R square. You need potential. Do you remember any relation which can convert field into potential?
E is equal to V by R.
E is dV by dr. But in that relation, if you are using this relation, E minus of dV by dr. When you do this is relation when potential is given and you are supposed to calculate field. But the problem is just reverse. Now you have field, but you need to calculate potential. What you will do? You can arrive at the result using this expression also. Apit, can you think you have field? You're supposed to calculate potential.
Sir, EDR.
Yes, if you want to calculate potential, just integrate your field. Fine. It's minus of integral. That is. So if you have potential, differentiate potential with respect to position and you will get field. But if you have field, then integrate field with respect to position and you will get potential. That's it. So this is field which is A by R square. The potential is integral of E dot dr. Integral of E, which is A by R square into dr. So you can take this minus A outside. The integral of 1 by R square is minus of 1 by R. Now assume that you know how to calculate, how to integrate. So V is A by R. Once you have V is equal to A by R, you can calculate V1. Huh? For calculating V1, just have to substitute the value of R1, which is 9. And here R2, which is 9 again. See, this minus 9 sign is just a coordinate. It will not come in your calculation. So when you want to calculate V1, just put A and instead of R, you can substitute 9 into 10 raised to the power minus 2. It's centimeters. So that is V1. Similarly for V2, what you can do is you can just substitute it here. 9 into 10 raised to the power minus 2. This much volt. This much. So now you have V1 also. You have V2 also. You have Q1, Q2 and everything. Substitute the values. It's Q1. How much is Q1? Q1 is 7. Is it clear now up to here?
Yes, sir.
Yes, sir.
Now just substitute the values. So you have Q1. Q1 is it's 7 microcoulomb and Q2 is minus 2 microcoulomb. Substitute the values. For here Q1, just write 7 microcoulomb. So it's 7 into 10 raised. Wow. Then you have V1, which is A by 9 into 10 raised to the power minus 2. Then you have minus 2 microcoulomb also. So Q2, which is minus 2 into 10 raised to minus 6 into A by 9 into 10 raised to the power minus 2. And then you have this term also. We have already calculated this term, which is minus of 0.7. So this is, and the value of A is given. So this is how you can calculate potential energy when you have interaction of charge. So this will be a tough question of potential energy. But this is all example of NCERT. It's when you look at previous years, I believe only in last 6-7 years, only once they asked this question. But anyway, it's a solid example of NCERT, so it can come. If your paper is going to be very tough, then they will ask this question.
Sir, how did you calculate the distance between the charges? 18.
It's minus 9 and plus 9. This is origin. Minus 9 means left to the origin 9 centimeter. Plus 9 means right to the origin 9 centimeter. So here to here, it will be 9 plus 9. Na? 9 this and 9 this.
Oh, okay, got it. I was subtracting it.
Separation. Okay, just note it down. Then move on to third type of question on potential energy. Did you solve those questions that I asked you to solve? Like I'm taking some questions, na?
Yes, sir.
Don't skip those questions. Those are important ones. See, if paper is coming out to be easy, then you won't have any issue. Even if you know derivations, formula, then you can attempt. But the point is, if it is very, very tough, then they can ask these type of questions. I can't cover all questions in just 1-2 weeks, but I can cover few questions in the class and then give some for the homework also. And if you can check, yes.
So I wanted to do AC again. So can you arrange accordingly?
Just send a message on that operations number, the number of the operations team. They will arrange a class of AC.
Okay, sir.
You can contact them directly. If you wait for me, then something gets slipped from my mind. Just text them.
Okay, sir.
And it's for all of you. Like if you think that you want to revise something, you need 1-to-1 classes for something, just text on that number. They will arrange. Can I scroll now? And please, before going for your final exams, go through the questions of the test series. I picked those questions keeping in mind that if paper is very tough, then what type of question they can ask. Even if you have not attempted the test series, just you have those question papers on your group. Just try to, and along with the solution, just go through those questions and make sure before you go for your final exams, you went through all those questions.
So can you share that important question bank, sir? You were saying in the yesterday class.
Yes, that I'm preparing, but before that question bank, just go through that mock test. Like I prepared all those question papers of mock test. So when I make again a list of important questions, 60% will be from that mock test series only. Can I scroll now?
Yes, sir.
Okay, there is one more thing in potential energy, that is the potential energy of dipole. So there's no question on dipole. Let's see. Point charges, then. What's the definition? This is potential due to point charge. Just one second. Just 1 second. Let me find questions on. Okay, so from dipole, there is no questions in PYQ. They just ask the derivations. Fine. See, if you have electric dipole, just remember some relation. This is
Sir, I have a doubt in this derivation, sir.
okay. So I'm just writing the relations. Arpit, you can discuss the derivation at the end of the class. Because if I discuss derivations at this time, I can't even cover the first book. So before your final exams, I want to cover all the tough questions from the first book. So this is electric field. In electric field, you place the dipole. The dipole moment is P, angle is theta 1. So you want work done to rotate this dipole from some angle theta 1 to angle theta 2. So the work done is, the expression of work done is minus of P cos theta 2 cos theta. This is the expression of work done. An external field in rotating dipole from angle theta 1 to theta 2. This is work done by external force minus PE cos theta 2 minus cos theta. Now, if you want to calculate work done by electric field, the work done by electric field is negative of work done by external force. You can, so it, if you know work done by external force, you can calculate work done by electric field. And then there is relation of potential energy difference. Potential energy difference is just negative of, not negative. Potential energy difference is always equal to the work done by external. And then this is the work done when you are rotating dipole from angle theta 1 to theta 2. This is the work done by external force. This is work done by electric field. You can write that change in potential energy is work done by external force, and then you can do one more thing, like you can also write the expression of potential energy as minus of PE cos theta, or you can write this as minus of P. So see, the difference between this and this relation is, in this relation you are calculating potential energy difference when your dipole is rotating from theta 1 to theta 2. Here you have electric field and you place your dipole at some angle theta 1. You're not rotating it, you just place it at an angle theta. Then your potential energy is minus of P. Just note down these relations, we'll do one question on it.
So your work done of external field is negative of work done.
Work done by electric field is negative of work done by external force.
Okay, sir.
Tell me once you have written all these relations. We'll do one numerical over it.
I'm done, sir.
Nazia, Sakina, Anshika.
Done, sir.
Okay, let's solve this question. When I say position of stable equilibrium, that means theta 1 is 0 degree to unstable equilibrium. Theta 2 is 180. Hence calculate potential. Do it and write your answers in chat. The dipole moment is given as 2 coulomb meter and the electric field is 5 Newton per coulomb. Do it now. Answers. It's okay. I got an answer from Arpita. And what about the rest? If you want, you can use these values. Cos 0 is 1, cos 180 is minus. Good, Nazir.
So we will have to learn the values till 360.
But not all. Like after 90, you should remember 180, 270, and 360. 360 is same as that of 0. That's it. Sakina, the negative sign is wrong. Hishma, Anshika. Hishma, just check the value of cos theta you are using. Anshika, answer.
Sir,
Yes.
sir, if it would have been said like we have to calculate the potential energy, sir, the answer would be same.
Yes, answer would be same. So, let's calculate work done. Work done by external force. It's simply minus PE cos theta 2 minus cos theta 1. So work done by external forces minus of P, which is 2, E, which is 5, cos theta 2, which is cos 180, cos theta 1, which is cos 0. So it's minus 10, it's minus 1, so that comes out to be plus 2. So this is the work done by external force. Now, along with work done by external force, if you want to calculate potential energy difference, that's exactly equal to work done by external force, which is plus 20. A simple formula based. Note it down. Anshika, clear now?
Yes, sir.
Sakina Abbas, did you revise those chapters which we asked you to do? Like, they must have told you to
Yes,
revise.
sir.
You revise everything, huh?
Yes,
On
sir.
physics. So today you have that session
Yes, sir, at 8.
at 8. Okay. In that session, if you have doubts, just first clear those doubts and then they will ask you to solve some assignments. Huh? Just make sure that today, by the end of this 12 p.m., those chapters are strong. Those chapters get finished. Huh? Okay, now let's move on to the next question. So that was about potential energy. Now the next thing is capacitance. Okay, if you want to list the formula that we use in capacitors, then the first relation is Q is equal to CV. C is equal to Q by V. Another point that you should always remember is C is independent of Q and V. Okay, just one thing. Nazia and Sakina, do you have link of this notebook?
No, sir.
No, sir.
Okay. Other Arpit, you have link of this notebook, na? Okay.
Yes.
Yes, it will take few time. I'm sharing the link on in the chat room. It's a very heavy file, so it will not open in your mobile phone, but it will work well in your desktop. So this have everything, like right from the first lecture. Don't go through these things. Just new section. Yes, from here, chapter 1, electric current, and it's capacitors. It's everything. Like it have complete notes along with numericals, everything. If you can go through it, then it's enough for your say basic syllabus. So you can refer it as notes. EM waves you have, then you have modern physics, Then you have wave optics also. Then you have complete ray optics. Then again, a modern physics. It just don't have one topic, and that is semiconductors. For semiconductors is a different book. Yeah, that's semiconductor. If you're following these notes, then you don't need any book. It's complete in itself. So Q is equal to CV, C is Q by V, the first relation. Then you have relations for types of capacitors. Like the first one is spherical capacitor. So if you have a spherical capacitor, then the relation of its capacitance is 4 pi epsilon naught R. Then you have parallel plate capacitor. In parallel plate, you have several cases. The first case is with air. So you have two plates, plate area A, separation between them is D. The capacitance of this parallel plate capacitor is epsilon naught A by. Then with air, you can have with dielectric slab. In that case, this is parallel plate capacitor. You fill the entire space with a dielectric. Entire space with a dielectric. So in that case, the capacitance is K epsilon naught A by D. And the third case is dielectric is partially filled. Dielectric is partially filled. So in that case, your C will be K epsilon naught A over D minus T plus T by D. Then you can have a conducting dielectric partially filled. So when you, sorry, not dielectric, but conducting slab. If you have a conducting slab, then your C will be its K epsilon naught A over D minus. Then you have expression of potential energy, which you have three expressions. One is half CV square, another is half Q square over C, another is half Q. Half Q. Note it down. Note it down. These relations, they will do numericals.
Second scroll.
Mhm. Okay. It's too few questions. Okay, this is an easy one. First question. Do it and write your answer in chat. Okay. Okay. So see, this is Q versus V graph. You're supposed to calculate so you're first supposed to calculate the capacitance. See, if you calculate the slope of this graph, then slope is always y coordinate divided by x coordinate. So if you do q by v, then q by v is c. So slope of the graph will give c. This is the angle for the B capacitor. This is the angle for the A capacitor. Obviously, A is greater than B. So CA will be greater than C. So now what you can do is you can just now check. So CA is greater than C. You know the capacitor A have greater capacitance than capacitor B. Now it's given Q versus two capacitors. Both have same plate separation, but area of C2 is greater than C1. So what you have to do is you have to decide out of A and B which one is C1 and which one is C2. Now let's first calculate C1. Huh? What is C1? C1 is epsilon naught A by D. And let's call this as A1 and C2 is epsilon naught A2 by D. So if you compare this, A2 is greater than A1. Plate area of C2 is greater than that of C1. So A2 is greater than A1. That means C2 is greater than C1. If C2 is greater than C1, that will means the CA is C2 and CB is C1. C1 is C2 and C1 is this one second. C1 is B. Or I'm doing wrong. One second. So C2 is greater than C1 and here CA is greater than CB. So the greater one is C2 and the smaller one is C1. So what is C1? C1 is CB is right. C1 is B.
Sir, I didn't get this. Can you explain?
Do you know how to calculate slope, Arpit?
Yes, sir.
How to calculate slope? Y coordinate by
Y
x
coordinate by x
Q by V,
coordinate.
this is.
Yes, sir.
And you know that slope is equal to tan theta.
Yes, sir.
So for which line theta is greater for A or B?
Sir, for A.
For A it's greater. So you write this as CA is greater than CB.
Yes, sir.
And now calculate the capacitance C1 and C2 from the given data. Same plate separation, but area of C2 is greater than that of C1. So if you want to calculate C1, that will be epsilon naught A1 by D. And if you want to calculate C2, that will be epsilon naught A2 by D. So which one is greater, A2 or A1? It's given, na? Area of C2 is greater than A1. So which one is greater, C2 or C1?
C2.
Now you have to decide out of A and B which one is C2 and which one is C1. Obviously, greater one is C2
Yes.
and smaller one is CB. So which one is C1? Smaller one, B. Because B is slope of B is less. If you look at here, now B is C1. And why B is C1? Because slope of B is less than A.
Yes, I got it.
Do it now. Do question number 2. But remember, from capacitors, usually you get circuits. Do it, question number 2. Answers? This is again PYQ of CBSE. Okay. Answers? Okay, Abid. See, the formula based thing, na? A capacitor, unknown capacitance connected across a battery of V volt. The charge stored in it is C. So the formula of charge is CV. So you can write that Q is equal to CV. Q is 360 microcoulomb. Remember, we are taking Q in coulombs, so C will come in microfarad. That's first equation. When potential across the capacitor is reduced by 120 volt, the charge becomes 120. The capacitor potential is V minus 120. That's equation 2. You can simply divide 1 and 2. So when you divide them, this is 360 divided by 120 is CV divided by CV minus 1. C will cancel this. C 120, 3s are 360. So when you multiply, this is 3V minus 360 is equal to. So you get 2V is equal to 360. You get V is equal to 180. So if you have V, you can substitute the value of V in any of the equation and get the value of C. Is it clear now?
Yes, sir.
It's a simple question. Do it. Okay, written. So today we'll stop here. In the next class, we'll try to finish this capacitance, and the next topic will be current. So try to solve some questions from capacitance and revise current before the next class. The next
Sir,
class, we'll be discussing circuits of capacitance. Yes, sir.
so can you give a gist of that derivation?
List of derivation, I have shared on the group now.
Sir, I was searching for it, but I didn't get it.
There's one PDF on the group. Well, I'll ask them to share it again. There's one list of derivation on the group, na?
Yes, sir.
There is one. Okay, I'll share it again. Fine. So today I will stop here. In the next class, we will continue with the circuits and with